So, okay, so this is a presentation that the paper that Marcel and I have worked on. We have presented this in other conferences before. Is the idea is to find a way to represent voting with intensity of preferences. In other words, when you try to make a voting in general, if you allow people to have intensity of preferences, then not everybody's vote counts the same, so to speak. That would be the fear, right? So I think that this presentation is available to everybody. So I'm not going to read all of it. 15 minutes too short for the whole problem. But what we would like to do is to not allow fanatics to make decisions. So in this case, we assume that everybody is just nice and conservative. Not, well, the word conservative is a little strange, but they have moderation. Okay. So the question is, how do you vote one candidate versus another, and you represent the intensity of preferences? Now, of course, that's not going to be that simple, but there's a way to do this without having to actually represent your preferences. Okay, and that is using ranks. So that's the reason for the word full rank voting. So what we would like to do is capture that intensity of preferences when you are choosing between candidates in the voting process. So voting is not the same as decision making in groups. In groups, you try to get consensus. If what you try to do is count the votes, then at that point in time, then you have to do ranking, but you have to rank all the candidates, so to speak. So I'm going to show you. There's a country in the world that does that, as in Australia. So in Australia, for the parliament, for the vote to count, you have to rank all the people who are running for whatever the position is. If you leave somebody blank, you only choose one of them as number one, then the vote doesn't count. So you have to put everybody there. So you try to measure how the voters prefer the candidate. So voting is not the same as I said before, it's not the same as decision making in group, because consensus would require more or less the ability to represent all the judgments together is almost like an average. In fact, Tom and Jen Chiang, another colleague, wrote a paper about using the geometric mean to represent voting, but that's not the right way to do it. In fact, by the way, voting is not enough. It's not only used for the election of officials, government officials. It's also used in other areas. For example, to allocate funds for different projects, and the judges, so to speak, take the different projects and they rank them. Which ones would are more preferred to them, and they give them maybe some scoring, so to speak. I have some references here about who has addressed this issue before. For example, Cook et al. Allocation of ranking tasks to individuals in the context of NSF process. NSF gives money to different projects, and they try to find out which one they want to fund. So you are ranking basically. You have a reference here as management science. With another person by Hochbaum and Levine, where they said, okay, should we use assign criteria and assign weights to the criteria? You have preference rankings, intensity of rankings, weights and rankings. So in general, in that process, when one project is preferred to another, the number of votes that in which you prefer I to J minus the number of votes you prefer J to I, it has to be positive. You prefer I to J. So but they're using negative numbers, additive. We don't use additive numbers. We use intensity of preferences using a pair comparison, how strongly you prefer A to B, and then you have to have an intensity. The problem is that you can't ask every voter to provide that intensity, because then you say, well, how do you, maybe if I don't give you enough intensity, then you may think that my vote counts less. And that's not the issue. The issue is how do you represent it? So in general, if you had to prefer two things and you put in intensity A in whatever the scale you want, If you make that A very, very large, you notice that the priorities become 1 and 0 rather than just normalized priorities like that, right? So there is a way to combine the preferences of the voters in such a way that if instead of just using intensity, you do the counts. The counts is the extreme. Something is extremely preferred more than the other. Then you become ordinal preferences, counting. Remember the scale, I don't have to tell you what the scale is. We already know it. So when you have, I don't know if this is too small or not, but when you have n people voting, you have people who prefer A to B. I only have two candidates right now, but we can extend it to any number, really. So the ratio, the number of people who prefer A to B over the total number of voters, that's the priority of the people who prefer A. Okay, so that is just basically, if you count the number of votes divided by the count of votes that we prefer to A, that is a reciprocal comparison, and you get the priorities, is the eigenvector. And if you had many, many, many people voting, the way to combine them is, you can see here, it's a mathematical expression here, is you take not the count, but actually similar to the count, so that when the votes become, the intensity becomes infinite for all of them, it converges to the matrix of counts, which is the actual voting situation. So what I'm trying to say is that if you rank the candidates, it approximates the votes when the number of people voting is very large. If you have three matrices, three people, if you are counting, for example, A preferred to B versus B preferred to A, and you put a reciprocal of B with respect to A, notice that this matrix is a reciprocal matrix, but it's not consistent. So the only thing that we would like to have is called row dominance. The rows dominate. In other words, row dominance means that it's a necessary and sufficient condition for having rank preservation. So if you eliminate the candidate, when you spread the votes, that candidate gets to the others, the priorities, the ranking remains the same. So there you have it. So what we would like to say is, if you use intensity of preferences, which is the ratio the A preferred to B, these are the intensities. If you mix them, if you combine them this way, then you're going to get, in the limit, when you have a very large number of voters, something very close to using counts. So to do that, they say, well, okay, how do you test this? Well, let's assume you have only three candidates, just to make it simpler. And so we did a simulation using this approach, using the scale 1 through 9, Tom's scale, obviously. And you can see, for example, you start with a simple example of 3, and this is, for example, this is randomly generated. If you generate the rankings are random, obviously you're going to get, in the limit, you're going to third. That's what you expect to have. So if you assign intensity, you do a simulation, you get numbers. This is for only 10 voters, but if you keep increasing the number of voters, n equal to 100, you can see that the priorities converge to a third. And if you continue with the larger numbers, for example, 100,000, you can see that the number of counts, this is the intensity of preferences, remain almost the same, okay, as if you were to do the count. So intensity of preference and counting, when you do ranking of all of them, tend to converge to each other. But of course, this is when you have a large number of voters. But when you do voting, you don't just do 5 or 10 people. You're talking about political candidacy, for example, right? Even when the rankings are not equiprobable, they have, some rankings are more important than others, so more prevalent. If you do a simulation, you notice that, for example, only for 100 people, you can see the priorities are very close. I mean, I can reproduce this all the time. It's an Excel. So in order to, it's actually, I wrote the program in Lisp to do it. So to test this, I took the elections from the gubernatorial Democratic primary election in Maine, the state of Maine in the US. And this is what some of them were missing. You see, some of them, somebody just voted for one. So to accommodate that lack of information, what we did is we said, okay, see, if one person only votes for one, for example, E was the preferred candidate, 0 through 6, that was the number. So 7 means that it was not ranked. Then we assume that this is a half and half. The matrix that particular ranking generates is something like this, where E dominates here, and then the others are half and half. They are equally preferred. So we don't. So if you do that, actually, you're able to see that uh, if you use the voting matrix with the ties, you allow for ties, you can see that if you normalize the two preferred candidates in this case, the priorities coincide with the, if you do the matrix intensity of preferences are very similar too. And actually, uh, these are the numbers that come out in the actual, when they did rank voting. So rank voting, what they do is you rank the candidates, and the one who gets the least number, if somebody gets 50% or better, then you stop. If not, then you do start eliminating candidates. It turns out that the matrices of counts like this have row dominance. So when you eliminate the counts, the particular candidate, you spread the votes to the remainder, and you end up with the same result. So that was for 150,000 or something like that, number of people. We use this also in another application. They use it in the south of Spain to find out which localities in the south of Spain people like best, the tourists. So, so basically, what we did is they ask people at the airport. It's like a you know what do you call it, a convenient sample, because people at the airport were just coming from vacation. This is an important problem because which locality should I help to put more money to make it more attractive? So about $7 billion, a billion euros actually, was in 2017. So if you notice that in the experiment, they did the typical tell me 1 through 5, the Likert scale, or use the approach that we have here about which one, give me the ranking of the localities, and then use the eigenvector method. And it turns out, here, let me show you. The EMPV was the result. The visitors is the red one. They are not as far apart as you think. If you do correlation of the result, you see that the eigenvector method with the counts is closest to the actual than the others. And so when you do the actual predictions, you can see that the EMPV is pretty close to the actual results. I mean, of course, this is an experiment. So what do you use this for? Well, you could use it, for example, to find out what are the attributes of the social media, like electronic games. What are the priorities of the criteria? So instead of asking people to do intensity of preferences, you can actually have ask a group of people to tell you about how they prefer, which criteria they prefer in terms of rankings, and then you accumulate those rankings in terms of the process that we present here, doing a pairwise comparison matrix of voting as opposed to doing intensity of preferences. So you don't get a consensus. What you get is a voting result. This is one of the papers that was published with that information. This is very fast, obviously. So I'm going to stop here. 5 minutes, so to speak, right? So if somebody wants the paper, we can send it. It's easier to read than to tell it to you in 15 minutes. It's a longer paper because it introduces the idea of how you should combine the judgments, and then a simulation to show you that if you do ranking rather than intensity of preference, it's almost the same, provided that you have a large group of people making that decision. Okay, but it doesn't substitute intensity of preferences. That is a different problem. So the major issue here is that voting is not the same as decision making in group. Notice, for example, the elections in the US, right? If you were a decision in group, it would be different because the average is not what came out. I went very fast, but I don't have any other way of doing it. So if you want the paper, we can send it to you. We are rewriting it because we sent it for publication. And unfortunately, this presentation, I did it in Porto, Portugal, in June, but I had 30 minutes longer than this, much longer. But 15 minutes, it made me afraid of making the presentation. because it doesn't give you a chance to present everything. And obviously, I'm not going to be reading the transparencies because that's horrible, number one. Number two, it just doesn't have the richness of reading the paper. So anyone who wants to understand the problem better, I'll be glad to send the paper. Although there is a shorter version in the proceedings, obviously.
May I ask a question, Luis?
Sure.
Yeah. Let's say mathematically, this makes a perfect sense, etc. But how would that be feasible to really implement this in actual reality,
Mhm.
dreaming for presidential election or something? Or do you think it's going to be, what are the obstacles to implement this
Well,
in reality?
the Australians use the method for their candidates, right? And so if you would do if you want to represent intensity of preferences when you are voting, because they are ranking all of them, what I'm trying to tell you here is that you should rest assured that your intensity of preferences are taken into account. Now, if you want to do the same thing in a different, like for example, in some places in the US, they do rank voting, but they don't rank all the candidates. So some of them are left out. They said, I have a number one, but the others, they are all the same. The way you have to put it together is you have to assign, instead of a one to the most, half to the others. You divide, and that allows, compensates. But that is only, so what I'm saying is that if you want to use intensity of preference in voting, you have to rank the candidates. It's the easiest way to do it. You don't have to ask everybody to tell you, I prefer candidate A to candidate B strongly, and I give you a 5 according to a criterion. So you will have to do ranking for every criterion, right? And then you have to do the criteria. And so how am I going to get the weights of the criteria? So I got to rank them again, right? So I can't substitute the idea of pair comparisons. So obviously true. But if you do voting, at least in voting, now I have not had, as I said, the only other example I have is that example in the south of Spain, where they ask the people rank the cities that you like the best, right? Because you visited them, versus using, for example, give me 1 through 5 Likert scale. Uh, but they didn't do pair comparisons and give them this is more preferred than that strongly. They didn't do that. Okay, they only did count. So the only way we are able to prove something about intensity of preference is if I do the simulation. You say, see, if you have a large number of people and they all rank the candidates, it turns to be very close to the idea of intensity of preferences. So I'm thinking, if you really want to consider intensity of preference of people, you should do count. You should do rankings from which you abstract the priorities. But that, as I said, that is not the same as decision making in group. It does not substitute the pair comparison with intensity of preferences when you do an actual particular decision. Okay, so that's it's not intended for that purpose. It was only answering the question in my mind: can I incorporate intensity of preferences in voting? That's it. But you don't do intensity of preference and then you do the geometric means. If you do that, you don't get the right result. You get an average, and the average wouldn't be the right result. I have an example in a different paper that published in 2016. Um, so publishing a paper in a given version also creates problems for the future, right? Because they would say, "Oh, you already published the properties of the method over there." Yeah, but I'm trying to show you something else. That is, if you rank, you should be rest assured in a voting process that your intensities are considered in the limit. So that's the story. Very simple idea. But I'm not taking away anything else. I'm not superseding anything else in terms of prioritization. It's only for the voting process.